Hello students, welcome to Yupp Master. This is 11th class IIT Live. I am Radha Krishna, mathematics teacher. Today we are going to continue sequences and series. First we are going to solve few problems on sigma pi methods and then we will proceed to double sigma and triple sigma models. Alright. First, let us take up the question. Find the sum 1 into 3 into 5 plus 3 into 5 into 7 plus 5 into 7 into 9 and so on till n terms. In this, every term has 3 factors which are in AP with common difference 2. And first factors 1, 3, 5 and so on, they are in AP with common difference 2. Second factors are also in AP with common difference 2. Third factors are also in AP with common difference 2. Then nth term is not given. So let us find the nth term of this series. Tn is equal to, first, what is the first factor of the nth term? If you observe the first factors 1, 3, 5, next 7 and so on, this is AP. What is the nth term of this AP? A plus n minus 1 into D, that is 1 plus n minus 1 into common difference is 2. So what is it? 2n minus 1. So first factor of the nth term is 2n minus 1. Now second factor is first factor plus 2. If you observe the terms, every second factor is first factor plus 2. Third factor is second factor plus 2. Alright. So first factor is 2n minus 1. Second factor will be 2n minus 1 plus 2, that is 2n plus 1. Next factor will be 2n plus 3. Alright. Now sum of the n terms is Sn is equal to sigma of nth term, that is sigma 2n minus 1 into 2n plus 1 into 2n plus 3. Alright. Multiply these three. First 2n minus 1 into 2n plus 1 is 4n square minus 1 into 2n plus 3. Alright. Now again multiply these two. You will get sigma 4n square into 2n, 8n cube. Next third degree term is over. So now second degree term 4n square into 3 plus 12n square. Next first degree term 1 into minus 1 into 2n minus 2n. And constant term will be minus 1 into 3 minus 3. Alright. Now if you apply sigma to individual terms, first term is 8 into sigma n cube. What is sigma n cube? N square into n plus 1 whole square by 4. Alright. Plus 12 into sigma of n square. Sigma of n square is n into n plus 1 into 2n plus 1 by 6. Alright. Minus 2 into sigma n, that is 2 into n plus 1 by 2. Minus sigma 3. Sigma 3 will be 3n. Now we need to simplify, cancelling 4, you will get 2 into 2n square into n plus 1 whole square plus 2n into n plus 1 into 2n plus 1 minus n into n plus 1 minus 3n. Now you can leave the answer like this, or if you want to simplify further, expand the squares, multiply these brackets, and finally write it as a polynomial in n. It will be a polynomial of degree 4. Alright. This is method 1. We have another method also. We can find the sum of the series by using telescoping series. Let us again take the same question. 1 into 3 into 5 plus 3 into 5 into 7 plus 5 into 7 into 9 and so on. What is the nth term? We got 2n minus 1 into 2n plus 1 into 2n plus 3. 2n minus 1 into 2n plus 1 into 2n plus 3. Alright. We want to find the sum of these n terms Sn in the second method. Alright. How to write it as a telescoping series? In telescoping series, we write nth term as a difference of two terms. So, let us take nth term. It is 2n minus 1 into 2n plus 1 into 2n plus 3. We have to express this as un minus 1 and then expand the telescoping series. To write this as un minus 1, what we do is we multiply by difference of the factor next to this last factor and the factor before the first factor. What is the factor next to 2n plus 3 in the same order? See, this plus 2 is this plus 2 is this. So, next factor will be 2n plus 5. Difference between 2n plus 5 and the factor before this in the same order, if you go left, you will get the next factor before 2n minus 1 will be 2n minus 1 minus 2, that is 2n minus 3. Take 2n minus 3 here. If you write it as difference of these two, what is the difference? It is 8, but we do not have 8 here. So, multiply by 1 by 8 so that the value of Tn remains same. Now, multiply these three factors with this and express it as a difference. 1 by 8 into 2n minus 1 into 2n plus 1 into 2n plus 3 into 2n plus 5 minus again same 3 into this. It is 2n minus 3 into 2n plus 1 into 2n plus 3, 2n minus 1 into 2n plus 1 into 2n plus 3. Now, if you observe, if n is replaced by n minus 1 in the first term, you are getting this. So, if you take 1 by 8 into this product of 4 factors as un, then the second term is 1 by 8 into this product of these 4 will be un minus 1. If you take 1 by 8 into product of these 4 factors as un, then minus 1 by 8 into product of those 4 will be un minus 1. So, nth term is expressed as a difference. Now, Sn is equal to, putting the values of n from 1 to n, you can write the telescoping series. Putting n is equal to 1, u1 minus u0. Putting n is equal to 2, u2 minus u1. Putting n is equal to 3, u3 minus u2 and so on. Finally, putting n is equal to n. un minus un minus 1. Alright. Now cancel the terms, u1 cancels, u2 cancels, u3 cancels and so on, un minus 1 also cancels. Alright. What are remaining? Minus u naught here plus un there. So it is un minus u naught. Substitute un. Un is 1 by 8 into product of these 4 factors. 1 by 8 into 2n minus 1 into 2n plus 1 into 2n plus 3 into 2n plus 5 minus u naught. How do you get u naught? This is un. So putting n is equal to 0 in un, you will get u naught. So u naught also will have 1 by 8 and putting n is equal to 0 here, minus this becomes minus 1 into 3 into 5. Then this product is minus 15, minus into minus is plus. So taking 1 by 8 common, you will get 2n minus 1 into 2n plus 1 into 2n plus 3 into 2n plus 5 plus 15. So this is the answer. In the first method, we got the answer as a polynomial like this. Still we have to simplify, but in this method we got the answer in a simplified form, in factorized form. So we can say that this is the better method. Alright. Let us proceed to the next question. Again, this is a problem on finding the product. Already in the previous class we have discussed that we can find the product of some terms only by expressing it as a telescoping product. What is a telescoping product? First, if you directly substitute the values of r from 2 to n, the product, that numerator and denominator should be cancelled diagonally. So if you take r is equal to 2, what are you getting? 2 cube, 8 minus 1, 7, 7 by this is 9 into, putting r is equal to 3, 3 cube, 27 minus 1, 26 in by 28, putting r is equal to 4, 4 cube 64, 64 minus 3, 63 by 65. And if you continue like this, no term is getting cancelled. So we cannot write it as a telescoping product. Then you try to modify this. How can you modify? You factorize numerator and denominator. Pi of r is equal to 2 to n. Numerator can be factorized as r minus 1 into r square plus r plus 1, and denominator can be factorized as r plus 1 into a cube plus b cube is a plus b into a square minus ab plus b square. So r plus 1 into r square minus r plus 1. Alright. Now we can write this product as pi of r minus 1 by r plus 1 into pi of r square plus r plus 1 by r square minus r plus 1. Alright. And in each pi, r varies from 2 to n. Pi represents product. Now, if you expand this expand this product, you will get, putting r is equal to 2, you will get 1 by 3. Putting r is equal to 3, you will get 2 by 4. Similarly, putting r is equal to 4, you will get 3 by 5. Next 4 by 6 and so on. Finally, putting r is equal to n. Here, let us substitute, take the last 3 terms of this expansion. Last term is n minus 1 by n plus 1, and before this you will get n minus 2 by n, and before this you will get n minus 3 by n minus 1. Alright, this is the first product. Now coming to second product, putting r is equal to 2, how much you will get? 2 square plus 2 plus 1 is 7 by 2 square minus 2 plus 1 is 3. Putting r is equal to 3, you will get 13 by 7. Next, putting r is equal to 4, you will get 21 by 13 and so on. Finally, putting r is equal to n square plus n plus 1 by n square minus n plus 1. Right. Now, if you observe this first product, it can be called as telescoping product because diagonally terms will get cancelled. Here first 3 cancels, then 4 cancels. In this way, from 3 onwards, all these factors till n minus 1 will cancel out. In denominator, starting from first factor up to n minus 1 will cancel. So, in numerator, only first 2 factors are remaining. In denominator, last 2 factors are remaining. 1 into 2 is 2 by n into n plus 1 is the value of the first product. In the second product, see 7 cancels, then 13 cancels. Diagonally, if you cancel the terms, n square minus n plus 1 will cancel. So, last factor of numerator and first factor of denominator will be remaining. So, what is the value of the product? N square plus n plus 1 by 3. Alright. So, final answer is going to be 2 by 3 into n square plus n plus 1 by n into n plus 1. Alright. This is the method of finding product of n terms by using telescoping product. Alright. Now, let us proceed to the next question. Find the 2020th term in the sequence 1, 2, 2, 3, 3, 3, 4, 4, 4, 4, 5, 5, 5, 5. See, 3 appears 3 times, 2 appears 2 times, 4 appears 4 times, 5 appears 5 times. So, n appears n times. This is the given series. We want 2020th number in this sequence. Let the 2020th number be equal to n. Then, if you write the series till n, you will get 1, 2, 2, 3, 3, 3, 4, 4, 4, 4 and so on. N will appear n times. N, n, n and so on n times. Alright. Now, n is the 2020th number. So, if you count from here, first term, second term, third term, fourth term, then 2020th number falls in this last row. Alright. That means, here how many terms you have written? 1 appears 1 time, 2 appears 2 times, 3 3 times and so on. What is the total number of numbers written? total number of numbers written is equal to 1 plus 2 plus 3 plus 4 plus and so on n. 1 plus 2 plus 3 plus 4 plus and so on till n. What is this? Sum of the first n natural numbers, n into n plus 1 by 2. So, this is the total number of numbers written in this list, but 2020 should fall in the last row. That means this n into n plus 1 by 2 should be greater than or equal to 2020. Alright. N into n plus 1 by 2 is greater than or equal to 2020. Then n into n plus 1 is greater than or equal to 4040. Now we have to identify the positive integer n. Here by trial and error method, if you just check large number 50 into 51 is around 2500, 60 into 61 3600, and it is 4040 now. So n should be greater than 60. Okay, 70 into 71 if it takes 7 sevens are 49, so 4900 is coming. So n should lie between 60 and 70. Now let us go one by one. If you take 61 into 62, it will not cross 4040. If you take 62 into 63, it will not cross 4040. 63 into 64, 63 into 64, if you calculate, you will get 4032. Calculate and check. So, if n is equal to 63, it is not satisfied. But if n is equal to 64, 64 into 65 will definitely cross 4040. Alright. So, what is the least value of n? It is 64. Therefore, we will take n is equal to 64. Alright. So, 2020th term in the sequence is 64. Alright. Therefore, 2020th term is equal to 64. Now, we are going to solve problems on double sigma, triple sigma summations. What is a double sigma? What is a triple sigma? I will explain through problems. First, consider the question sigma sigma I j, where 1 is less than or equal to I comma j less than or equal to 1. First, before this, you consider a product, a sum 1 plus 2 plus 3 plus 4 plus and so on till n. How can you write this? How can you put this in sigma notation? You can write it as sigma of I, where I varies from 1 to n, correct? Similarly, the same sum 1 plus 2 plus 3 plus 4 plus and so on till n can also be written as sigma of some other thing. Instead of I, we can write R, we can write J, we can write K. So, sigma j, where j varies from 1 to n. Alright. If you multiply these two, you will get 1 plus 2 plus 3 plus and so on till n into 1 plus 2 plus, or you can write directly whole square. if you multiply this and this, both are same, no? So we can write 1 plus 2 plus 3 and so on up to n whole square is equal to sigma of I into sigma of j. In each sigma we have to write limits 1 to n, j varies from 1 to n. Alright. Now this can be expressed as sigma sigma I into j. No need to write I after first sigma, j after second sigma. You can club them and write it as sigma sigma I j. I varies from 1 to n, here j varies from 1 to n. We can also write it as sigma sigma 1 is less than or equal to I and j less than or equal to n, I into j. So here there are two sigmas because there are two variables I and j, and I and j independently vary from 1 to n. That is the meaning of this double sigma. So what is its value? We know that this sum is n into n plus 1 by 2 and whole square is there. So this sum is n into n plus 1 by 2 whole square. So answer is n square into n plus 1 whole square by 4. Alright. Let us proceed to the next question. Here also we have double sigma. Double sigma 1 by 2 power I plus j. I varies from 0 to infinity, j varies from 0 to infinity. So I and j are independent variables varying from 0 to infinity. But we have 1 by 2 power I plus j as the general term. We can write 1 by 2 power I plus j as 1 by 2 power I into 2 power j, is it not? Write the limits, I varies from 0 to infinity, j varies from 0 to infinity. Now you can write sigmas in a different order, but after sigma containing I, you should have ith term, the term containing I. After the second sigma, you should have the term containing j. So we can write this as sigma of 1 by 2 power I varies from 0 to infinity, into sigma 1 by 2 power j, j varies from 0 to infinity. Alright. And what is the expansion of this sigma? If you substitute I is equal to 0, you will get 1 by 2 power 0, 1. If you substitute I is equal to 1, you will get 1 by 2. If you substitute I is equal to 2, 1 by 2 square, and so on till infinity. So this sigma is 1 plus 1 by 2 plus 1 by 2 square plus 1 by 2 cube and so on till infinity, and similarly this sigma is also same. So we can write whole square. And what is this sequence? It is an infinite GP. What is the formula for sum of the infinite GP? A by 1 minus r. A is first term 1 and common ratio is 1 by 2. So this sum is 1 by 1 minus 1 by 2, a by 1 minus r whole square. Okay, and 1 by 1 minus 1 by 2 will be equal to 2. So 2 square. Answer is 4. Alright. Next question. Here we have 3 variables I, j, k. That is why 3 sigmas are there. Sigma, sigma, sigma. We can write 1 by 3 power I plus j plus k is as 1 by 3 power I into 1 by 3 power j into 1 by 3 power k. I varies from 0 to infinity, j varies from 0 to infinity, and k varies from 0 to infinity. Now as we did in the previous question, separate the sigmas to individual terms, this, this and this. Then you will get sigma 1 by 3 power I into sigma 1 by 3 power j into sigma 1 by 3 power k. I varies from 0 to infinity, j varies from 0 to infinity, k varies from 0 to infinity. Alright. Now, if you expand this sigma, it will be a infinite GP. What is the first term? For I is equal to 0, it is 1, and common ratio is 1 by 3. The expansion is 1 plus 1 by 3 plus 1 by 3 square plus and so on till infinity. And this one is also same, this one is also same. So, the sum is going to be 1 plus 1 by 3 plus 1 by 3 square and so on till infinity. Because all are same, we will get whole cube. Now, apply the formula for sum of the infinite GP, a by 1 minus r. A is 1 by 1 minus 1 by 3 whole cube. This is 3 by 2, this whole thing, 3 by 2 whole cube is 27 by 8. That is the sum of this infinite series. Alright. Next question. This is also a simple question. Triple sigma is there. Sigma, sigma, sigma of n. You can write it as sigma of sigma n. When sigma n is there, I told you already, no need to write the limits of n. N varies from 1 to n. Wherever sigma is there containing some nth term n, we should take the limits of n as 1 to n. And we already know that sigma n is n into n plus 1 by 2. So, substitute the formula n into n plus 1 by 2. Alright. Now, write it like this. And in the previous class, we have discussed some important results. Sigma 1 is n. Sigma n is n into n plus 1 by 2. Alright. Next, sigma n into n plus 1 is nth term n into n plus 1 into next factor n plus 2 by number of factors 3. Similarly, one more result also we have discussed, that is sigma n into n plus 1 into n plus 2. What is it? It is nth term into n plus 1 into n plus 2 into next factor n plus 3 by total number of factors in numerator, it is 4. So, here we can write this 1 by 2 outside, it will be sigma of half of sigma of n into n plus 1. Sigma n into n plus 1 is n into n plus 1 into n plus 2 by 3. So, it becomes sigma of n into n plus 1 into n plus 2 by 3, 3 into another 2 is there. So, by 6. Now, you can write this 1 by 6 outside sigma. 1 by 6 sigma n into n plus 1 into n plus 2. Alright. Now, using this formula, you will get this as n into n plus 1 into n plus 2 into n plus 3 by 4 into 6 is also there. So, what will be the answer? N into n plus 1 into n plus 2 into n plus 3 by 4 into 6, that is 24. All right. Now next question. Now I have changed the question slightly. Find the sum sigma sigma 1 by 3 power I into 2 power I into 3 power j. But here I and j are not independent to each other. I and j vary from 0 to infinity, but I cannot be equal to j. How to find? All of you carefully observe the method and remember it. When there is a restriction on I and j, first we will find the sum without any restriction for independent I and j. Sigma sigma for independent I and j, we should write I varies from 0 to infinity and j varies from 0 to infinity. All right. 1 by 2 power I into 3 power j. What is its value? How to find its value? As we know, we can separate sigmas to individually for 1 by 2 power I and 1 by 3 power j. Sigma 1 by 2 power I, where I varies from 0 to infinity, into sigma 1 by 3 power j varies from 0 to infinity. All right. Now, if you expand this sigma, for I is equal to 0, you will get 1. For I is equal to 1, you will get 1 by 2, next 1 by 2 square and so on till infinity, which is infinite GP. Here, if you substitute the values of j from 0 to infinity, what will you get? For j is equal to 0, 1. For j is equal to 1, 1 by 3. Next 1 by 3 square and so on till infinity. All right. And this is infinite GP and that is also infinite GP. So, let us write the sum formula 1 by 1 minus 1 by 2, a by 1 minus r, a is 1, common ratio r is 1 by 2, into this one. This is also infinite GP, first term is 1, common ratio is 1 by 3. So, the sum is 1 by 1 minus 1 by 3, and how much is this? This is equal to 2, into how much is this? 1 by 2 by 3, that is 3 by 2. 3 cancels, we get 3. What is this? 3 sum of the series given when I and j are independent to each other, but restriction is I cannot be equal to j. Now let us check what happens if I is equal to j. If I is equal to j, then this becomes 1 by 2 power I into 3 power I. When I is equal to j, no need to write 2 sigmas. You can take only single sigma because there is only one variable, is it not? So, I am going to calculate the sum for I is equal to j. For I is equal to j, you will get only single sigma. Limits are what? 0 to infinity. But we have to write either in terms of I or in terms of j. I will put j is equal to I. Then you will get 1 by 2 power I into 3 power I, where I varies from 0 to infinity. Now, what is this? 1 by 2 power I into 3 power I can be written as 1 by 6 power I. I varies from 0 to infinity. Alright. Now, if we expand the series by taking the values of I from 0 to infinity, for I is equal to 0 you will get 1. For I is equal to 1 you will get 1 by 6. Next 1 by 6 square and so on till infinity. What is this series? It is infinite GP with first term 1, common ratio 1 by 6. Alright. So, what is the sum? A by 1 minus R, 1 by 1 minus 1 by 6. How much you will get? 1 by 5 by 6 or 6 by 5. When I and j are independent to each other, varying from 0 to infinity, the value of the sum is 3. When in this sum, because I and j are independent, I may be equal to j or not equal to j. We have calculated the sum for I is equal to j. So, what should we do? How to get the sum for I not equal to j? Sigma the same question, 1 by 2 power I into 3 power j, where 0 less than or equal to I not equal to j less than or equal to what is it, infinity. Infinity. Okay. If you want this, from the sum, from the value of the sum for independent I and j, we have to subtract the value of the sum for I is equal to j. So, this will be equal to sigma 1 by 2 power I 3 power j, where I and j are independent, minus sigma, only one single sigma for I is equal to j, I varies from 0 to infinity, 1 by 2 power I into 3 power I. So, from the total sum I am subtracting the value for I is equal to j. Then this is calculated as 3 and this is 6 by 5. So, how much you are getting? 15 minus 6, 9 by 5. Alright. Let us proceed to the next question. Find the sum of the products of the first n natural numbers taken 2 at a time. Very important, very good question. Sum of the natural numbers, sum of the products of the first n natural numbers taken 2 at a time. So, first we need to understand what is asked. We know that natural numbers are like this, first 10 natural numbers. We have to take 2 at a time and multiply and then add all such products. So, one should multiply with 2, one should multiply with 3, one should multiply with 4 and so on, one should multiply with n. So, those products are 1 into 2, 1 into 3, 1 into 4 and so on, 1 into n. We have to add. Similarly, 2 should multiply with all other numbers. Already 2 has multiplied with 1, so we should not take it again. So, 2 into 3 plus 2 into 4 plus 2 into 5 and so on till 2 into n. Alright. Similarly, 3 should multiply with all other numbers. 3 has been multiplied with 2 and 1 in the first 2 rows. So, we have to take 3 into 4 plus 3 into 5 plus 3 into 6 and so on, 3 into n. In this way, finally, n minus 1 will multiply with n. So, we have to find the sum of all these products. Observe that every product is taken only once. 2 into 5 is there, but 5 into 2 won't be there. Is it not? Now, you can notice that all these terms will be present in the product 1 plus 2 plus 3 plus and so on till n multiplied by 1 plus 2 plus 3 plus and so on till n. If you multiply these two, 1 into 2, 1 into 3, 1 into 4, all these terms will come, 2 into 3, 2 into 4, 2 into 5 and so on. See, all the terms of the first row are coming, all the terms of the second row are also coming, all the terms of the third row, 3 into 4, 3 into 5, 3 into 6 and so on, 3 into n, all are coming. In this way, finally, n minus 1 into n will be there. But you also notice that every term will be present in the expansion twice. See, 2 into 3 comes and 3 into 2 comes, and say 3 into 7 comes once and 7 into 3 also comes. So, in this expansion, every term of these rows will be present twice. Every term, take 2 into 5 or 3 into 6, it will be present twice. Okay. We want this sum, say this is S, sum of all these terms. But since every term of these rows will be present 2 times, in the expansion we will get 2S. In addition to that, we also have 1 into 1, 2 into 2, 3 into 3, which are not there in any of these rows. What is 1 into 1, 1 square, 2 into 2, 2 square, 3 into 3, 3 square and so on, n into n is n square. So, those are the extra terms which we do not need. So, we need to subtract. So, first I will subtract the extra terms 1 square plus 2 square plus 3 square and so on n square. In all remaining terms, every term of these rows will be present twice. So, how to get this sum? We have to divide this by 2. Dividing by 2 means what? Multiplying by half. Alright. So, what will be our answer? Half into 1 plus 2 plus 3 plus and so on up to n into 1 plus 2 plus 3 and so on up to n is 1 plus sum of the first 10 natural numbers whole square. That is n into n plus 1 by 2 whole square minus 1 square plus 2 square, 3 plus 3 square and so on n square is n into n plus 1 into 2n plus 1 by 6. Alright. Now we have to simplify. N into n plus 1 is common in both the terms. Here this is n square into n plus 1 whole square by 4 minus n into n plus 1 into 2n plus 1 by 6. What is the LCM of 6 and 4? 12. So, it will be 1 by 2 into 12 is LCM. You will get here 3n square into n plus 1 whole square minus here you will get 2n into n plus 1 into 2n plus 1. Alright. 1 by 2 into 1 by 24, 1 by 12 is 1 by 24, and in numerator you can take n into n plus 1 common, okay, and remaining will be 3n into n plus 1 minus 2 into n plus 1, 2n plus 1 by 24. And finally, after simplification, you will get n into n square minus 1 into you will get 3n plus 2. by 24. So this is our answer. All right. Now we can write a general formula instead of the numbers 1, 2, 3 and so on. If the numbers are some general numbers a1, a2, a3 and so on, an, then the sum of the products of the numbers a1, a2, a3 and so on, an, taken two at a time. So we will take a1, a2 ones, a1, a3 ones, a2, a5 ones. In this way, we have to calculate the products and add. Then we have to follow the same working rule. So what will you get here? Half into, this formula is going to be half into a1 plus a2 plus a3 and so on an into again same. So a1 plus a2 plus a3 and so on an whole square minus of a1 square plus a2 square plus a3 square and so on an square. Half into a1 plus a2 plus a3 plus and so on an whole square minus of a1 square plus a2 square plus and so on an square. We can put it in sigma notation. It is half into sigma ai whole square. Sum from a1 to an can be written as sigma ai whole square minus, how do you write this? Sum of the squares of ai, that is sigma ai square. And all of you need to remember this formula. Sum of the products of any set of numbers taken two at a time is given by this formula. All right. Now let us proceed to the next question. Sigma sigma ij, where I is less than j, and I and j vary from 0 to n. Sorry, if I and j can vary from 0 to n, it is becoming 0, because if I is 0, it is 0. So let us change this. 1 is less than or equal to I, less than j, less than or equal to n. All right. Now what is its meaning? If you take I is equal to 1, we have to take all products in the form of I and j. So if I is 1, then j can vary from 1 to n. So 1 into 2 we have to take, plus sigma means summation, plus 1 into 3 plus 1 into 4 and so on till 1 into n. If you take the next value of I, 2, then 2 into j should be greater than 1, so j should start from 3 to n. So 2 into 3 plus 2 into 4 plus 2 into 5 plus and so on 2 into n. If you take I is equal to 3, 3 into 4 plus 3 into 5 plus and so on to 3 into n and so on. Now you should realize that this is nothing but the previous question. In the previous question, the question was asked in words. What is the question? Find the sum of the products of the first n natural numbers taken two at a time. But here the same is asked in notation. Alright. So in notation, this represents sum of the products of the first n natural numbers taken two at a time. Because here, why is the condition I less than j taken? Because you have to take every product only once. If you take I into j, we cannot take j into I. That is why an order for I and j is fixed. Is it not? So 2 into 3 will be there, but 3 into 2 won't be there. 3 into 7 will be there, 7 into 3 will not be there. That is why if the order of I and j is fixed, that means every product is taken only once. Alright. Let us proceed to the next question. Find the sum of the reciprocals of all natural numbers which are not divisible by any prime number greater than 5. An excellent question. We know that any natural number is formed by multiplying prime factors. Alright. Now, what are the prime numbers? 2, 3, 5, 7, 11, 13 and so on. These are prime numbers. So, if you want to form any natural number, then we should multiply some 2s, some 3s, some 5s, some 7s and so on. But here that number is not divisible by any prime number greater than 5. That means we should not multiply with any number greater than 5, any prime number greater than 5. That means the natural number should be formed using the prime numbers 2, 3 and 5 only. How many 2s you will take, how many 3s you will take, how many 5s, that does not matter. So, let the natural number be let us suppose we have taken I 2s, multiplying I 2s you will get 2 power I, and let us suppose we have taken j 3s, then the product will be 3 power j and similarly 5 power k. So, we can assume the natural number which is not divisible by any prime number greater than 5 as 2 power I, 3 power j, 5 power k. Now, we want here what about I j k? I j k vary from 0 to infinity. They are independent to each other. Now, what do you want? Sum of the reciprocals of all these natural numbers. So, required sum is sigma summation of reciprocals 1 by 3 power I, 2 power I, 3 power j, 5 power k. There are 3 variables. So, we should not use 1 sigma, we have to write 3 sigmas. So, it is sigma 1 by 2 power I, 3 power j, 5 power k, and I j k vary from 0 to infinity. And if you apply sigmas individually to 1 by 2 power I, 1 by 3 power j, 1 by 5 power k, it becomes sigma 1 by 2 power I into sigma 1 by 3 power j, sigma 1 by 5 power k. And we know that each sigma is in infinite GP. So, what is the value of this sum of the infinite GP with common ratio 1 by 2? It is 1 by 1 minus 1 by 2. Similarly, this second sigma will be 1 by 1 minus 1 by 3. And third sigma will be infinite GP with common ratio 1 by 5. 1 by 1 minus 1 by 5. Then this value is 2 and this value is 3 by 2 and this value is 5 by 4. Then the required sum is 3 into 5, 15 by 4. Alright. So, that is the end of the today's class. In tomorrow's class also we are going to discuss more problems on sigma and pi methods. Alright. So, we are going to solve some tough problems. Okay. Thank you for watching. See you in the next class.